Okay, I'm going to do a short demonstration of the GeoGebra software. Um, I've started out here on the web at the JohnnyO-Geogebra.org website, where you can go on for the free download, which is one of the nice features of GeoGebra, is the fact that it is free, and you have from this page here, you can go on to the download. You get the options of starting the web start, which once again installs GeoGebra on your computer, or you can go to an applet and nothing will be installed on your computer. It doesn't take up any of your hard drive space, and for many of you that are working on the cloud computing applications, that's where this would work out. Once again, this is a free software program, but generally I use the web start. Well, I'm using the web start, I should say, because I have the space on my computer, and I plan to work with it a lot more. But the so basically, when you click on this, it will download an icon onto your desktop, and that will run the GeoGebra on your computer directly. So I'm going to pull up something that I've already created here for a demonstration. I can't go too far into it because there's so much on this. This is a proof that I've done here for Euclid's second postulate. Now, there's a lot of different things here that you can work with when you're building something with GeoGebra. You have your buttons on the top. If you click, for instance, on this, it will give you a new point. So, and then if you want to make a line, you can make a line through 2 points. So you would click on this here, and then you could give yourself the point there, and then you could give yourself another point, and then you could click on the line through 2 points, and then you select the 2 points, and then you have your line. Now we're going to undo that. And take those off. There's a lot of different options on the view. I currently have the algebra view up, just to demonstrate the fact that this is not only useful for geometry, but also for algebra and calculus. But in this case, I was using it for a geometry demonstration, so you wouldn't necessarily need that. You can close that off. You can click on the algebra view, and it would take it off. But now, if you wanted to use it for algebra, you could also put in your Cartesian coordinates here, and which is given. And then if you had that along with the algebra view, then all these points make a lot more sense. So that's a handy thing to get you to. Actually, I'm going to bring that back out. To use it for different curriculums, depending on which class you might be instructing with that. Now, one of the best things about this is if you're going to do a demonstration of for instance, this is Euclid's second postulate, which is that you can draw a line of equal length to any line segment through a point not on that line segment. So what you can do is already have the proof built up, And then on the bottom here, you have keys to move forward on your proof. Now, so here you would start with a point, and then you would add your second point because you need a line. So then the next thing you would do would be to create, well, actually, yeah, you create a line through those 2 points. Now you have your line segment, and then you have your third point. This is what you start out with in the postulate, and then you progress from there. You make a equilateral triangle using circles, and now this is also set. You can do different settings on this. This is set for Euclidean geometry, to only use Euclidean tools. There is different settings up here under tools to allow you to use different tools that wouldn't necessarily be strictly Euclidean. But this is, like I say, a geometry demonstration. So then you have, you can create your equilateral triangle using the Euclidean construction. And then also we see here that I have gone ahead and put the marks on here to show that these are all of equal length. I did that after the construction, but you can do that with objects. You have points A, B, and C up here, and then you have your lines, segment A, okay, and now we have segment B, E, and F. As you can see, they're listed there. And if you wanted to, you can click on that, and it goes Object Properties, and you can put on a decoration. You see I've put the two bars there to show that it's congruent to the other segments B, E, and F. And I've also changed the color on that to make that a little more clear. But this is really nice in a presentation, especially for doing like a proof like this. Anyway, then you can go along and you can continue with the process and demonstrate this construction for this proof one step at a time. Now we have the construction as it goes along. Or, if you like, now when you get to the end here, what I've done is I've changed the colors, and then I have this line is congruent to this line, is congruent to this line. Anyway, I won't get into explaining how the process works, because this is, like I said, a demonstration of the software. But if you like, though, this is a real neat feature here. We can take it back to the beginning, and we can also play this as a series of constructions to kind of get the class to get a feel of how the whole thing flows along. So I mean, as you click through this one point at a time, somebody might get, oh, wait a minute, how did you get there, and how did this go along to there? Because as you're going along, you might get lost somewhere in the process. But with this, you can play it as sort of a video and then describe it as it goes along. And you can also select your speed on that and slow it down depending on how you are going to describe your construction. Once again, if you see over here, this is giving the C and the D is giving the equations of these particular circles as I create them on the construction over here. Incidentally, the construction, all these tabs up here are pretty straightforward as far as how you can construct whatever you would particularly care to make. And then you can also drag it and move your. You can click on drag here And if you want to move something that's already constructed, you can move the whole view here around on your thing. So if you had your axes here, you could move that to get a better look at it. But anyhow, that's some of the basics of it. But like I said, there's a lot more to it. But just some of these simple things. Some of the advantages to this are when you're making a line through 2 points with this type of digital construction, you don't need to use a straight edge. So some of the dexterity issues that some students might have to create that line between the 2 points and make it accurate, wouldn't, once that's highlighted there, you click it and you've got it. Same thing with the circle. You want to make a circle through here, and you can bring it out, and once that point's highlighted, there you go, you've got him. That's really helpful for kids that might not be as handy with the drafting tools as others, and it might give them a little bit of confidence. And in the same sense, you can go ahead and run this movie version of it, as a demonstration while they're trying to construct it. So if your purpose was to work on that dexterity and the mastery of the drafting tools, you could have this going over and over again in front of them there, so they know where they were going with the next thing, and then they wouldn't be as concerned with the actual construction itself as much as they would be with the accuracy and the actual learning of the use of the tools. So anyway, that's just some of the things that this program can do, and I really like it. I think it has a lot of applications. There are different applications for, like I say, for calculus and trigonometry. But I mean, right here you can see how it would really work well for geometry, at the very least, for doing your construction proofs, and as well for your algebraic representations of those constructions. So that's about it. That's GeoGebra. It's free. It's on the cloud, and it's a great tool for any level of mathematics, even past high school.